Okay, this is a continuation of the 6.4 notes. There were just a couple examples that we didn't do together in class that I said I would make a video for. This is 6.4. This is the example dealing with reference angles, part B. So if we're dealing with a 315-degree angle, if you draw your picture of what that would look like in standard position, remember that means that it has the origin as the center, and we have to figure out what is 315 degrees. Remember, this is 0 degrees, this is 90 degrees, this is 180, and the bottom is 270 degrees when we go around. So 315 is between 270 and, remember, this is also 360 for us. So if we draw a picture of that, we would go to the fourth quadrant. That is what the theta looks like. We want to know the reference angle, which means reference angle is always its relationship to x-axis. So we want to know this piece. So essentially, this is just 360 minus the 315, which gives us a degree measure of 45. So our theta of reference is a 45-degree angle. Now, in this quadrant, so I'm always going to redraw this picture again and talk about the triangle in this situation. So in this quadrant, we have this triangle that we can draw that has the, remember, it has that point right there. We just drop it perpendicular to the x-axis, and that creates a right triangle for us. Now, if it's 45 degrees here, that means the other angle is also 45 degrees. In our 45, 45, 90 triangle, the two legs were matching lengths, and the hypotenuse was square root of 2. So essentially, you could make these anything you want. They just have to match. And then when you use Pythagorean theorem, you get that number times the square root of 2. So we just try to keep things simple by doing ones. Now, we have to talk about signs here. The hypotenuse is always going to be positive. It's our distance of our radius for our circle, if we imagine drawing a circle here. 1 is on the x-axis here, and x is positive on the right side. It's negative on the left side. But our y value is down, so that means this is a -1 for the y value. So here's my reference angle, and so this would be adjacent to it. -1 would be opposite, and of course the hypotenuse has to be across from 90 degrees. So we're supposed to do, I believe, just 3 trig ratios. So sine of 315 degrees in quad 4 has a reference angle of 45 degrees, and so the reference angle, remember, has to keep the sign of what's going on in this quadrant. So sine is opposite over hypotenuse, so that's -1 over the square root of 2. If you wanted to rationalize that, and which we normally do, we multiply top and bottom by the square root of 2, so it's negative square root of 2 over 2. So that is the sine of 315 degrees. The cosine of 315 degrees is also related to the cosine of a quad 4, where your reference angle is 45 degrees. Adjacent over hypotenuse is what you use for cosine. So that would be 1 over square root of 2, and if we rationalize that, get the radical out of the bottom, it would be square root of 2 over 2. Okay? And then the final ratio for this one is tangent, which again is going to be related to a tangent in quad 4 with a 45-degree reference angle. Tangent is opposite over adjacent, so that's -1 over 1, or just -1. Now let's make sure all 3 of our answers make sense. Remember, in the regions, all teachers, or excuse me, science, I always want to say teachers first. All science teachers are crazy. So remember, in quadrant 4, the only positive trig functions are cosine and his reciprocal secant. So notice everything else was negative, and cosine here was positive. So that does make sense for our little saying that helps us remember when our signs are positive or negative. Okay, so the other example in this packet that I wanted to do was the one I had to add in because I didn't have, it for some reason wasn't on the document when it was originally posted. It's example 4. if cosine theta is equal to negative 0.3842, so notice this is a ratio, it's not the angle, it's a ratio that has already been divided and turned into a decimal. The key here is that we are now in radians, so radians, not degrees. We want to find this to the nearest 0.0001 radians. Okay, so first of all, we have to discuss when is cosine negative, because when we say cosine is negative, we're talking about the ratio of the triangles. So remember our saying, all science teachers are crazy. In this case, cosine is positive and cosine is positive. So the two cases where cosine is negative are the second quadrant and the, a negative number, is the second quadrant and the third quadrant. So quadrant 2 and 3 are our focus points. So that means we could imagine having a reference angle over here and a mirror image down here. Okay, so theta, cosine theta, is negative 0.3842. This says that we don't know the angle, but we do know the ratio. If you want to work with the theta and get that, you have to get rid of the fact that it's being applied the cosine right now. So we use what's called the inverse. Remember, we showed you this button on your calculator. So we're going to take the inverse of each side. So now cosine inverse and cosine are opposite operations of each other, essentially, so they cancel out and you just get theta. So now we need to use our calculator in radian mode, not in degree mode. So we need to push this while we're in radians. Okay, I worked this out already, and I got that my theta that they gave me was 1.965137,489. Now it goes on forever, but that's as far as my calculator went. So now we have to discuss how do we get solutions from this. So in this quadrant, our theta reference would be from here to here, and in this quadrant, our theta reference would be from the line that I just sketched in to the x-axis. So essentially, both of these are related to 180 degrees, but for us, that is pi when we're talking about radians. So to find one of the reference angles, we need to consider the case that is a little bit smaller than 180. So we will do pi minus that 1.965137,489. And for the other case, we're actually past 180, or pi, so we'll do the opposite. We'll say 1.965137,489 needs to be added to pi. Okay, so this part right here is this theta is our reference piece. Okay, so if we're trying to figure out what's the actual, I think I actually wrote this backwards. This is our reference angle, and these are going to be our thetas. Yeah, sorry, because the reference angle comes from taking that inverse. These are going to be the actual radians that we are when we talk about going from 0 to that line. So what I got for this first one, and I'm supposed to round it to 4 decimal places, is I got 1.1765 radians. And for the second one, I got approximately 4.3180 radians. Okay, so this one is in the quad 2, this one is in the quad 3. Okay, so that should be everything from that section.